Right. Static routing versus dynamic routing. Static routing. What is the difference? You see, to write static route, one should know the complete topology. To write static route, you need to know how many routers are there, which router is connected to which other routers, what all networks connected to each router, what are all the paths available to reach every destination, and what will be the best path. All this who should know? The administrator need to know. It means complete topology means what? He should know, he or she should know the whole network. The network, the routers, the wires, the best paths, every single bit information the administrator need to know to write the best static route. Yeah, it is possible if it is a small or you cannot say medium size, a small size or Soho environment, small office, home office environment. If it is a small network, administrator will know about the topology very well. He can write static route, which is not possible to know in a large scale, in a large network. That's another drawback to write static route. One should know the complete topology, otherwise he cannot write a static route. Second point, even if he writes static route, whenever a failure, whenever a link goes down, whenever a network goes down, whenever a router goes down, all the networks connected to the router will also go down. Then the administrator need to log into the respective routers which goes through the router which is failed, or the routers which goes to the destination to the networks that has gone down, has to remove all the static route that he wrote earlier. Isn't it? Otherwise, what will happen? All the packets will come, and when the destination is not found, the packet will be dropped. Let us assume you are all going to a destination, driving your own vehicle by looking into Google Map. When you started at home, the Google Map showed one path. But as you progress in your travel towards the destination, the road got blocked because of Ammayar coming that side. Ammayar is coming that side, so they blocked the road. If Google Map don't show you that, what will happen? You will go till that road where the block has been recently done, and then you have to now take a U-turn, find another route, and go to the destination. Instead, if Google immediately says the road has been blocked and these are the alternate path, would you like to proceed with the existing road or you want to move to the new path? If there is an option, of course, Google shows that option because Google is like a dynamic routing protocol. Google shows the option. Hey, Ammayar has come here. Ammayar has come. Like Kannadiga Google. Oi, Ammayar has come. Oh. So, do you want to take another path? Then you will say, yes, take me to the alternate path. That is Google, Dynamic Routing Protocol. But static route is not like that. Before you started from your home, you fixed your mind, okay, let's go through this road. Let's go through Beach Road. You took Beach Road to go to Paris. From where? Let's say from Velachery. All of a sudden, Ammayar is appearing. What will happen? From Santome, the road will be diverted. So after coming to Santome only, you come to know that, oh, the road has been blocked. We have to take another path. Now, when you try to take another path, problem. Already Triplicate is very hectic, packed. Now this road is also diverted, and this people also takes that same road. Not that easy, to go through Central Egmore. Take a big round, Park Station, and then Paris. Very difficult. If someone would have told you earlier, you would have taken another path. Straight from Velachery, you might have gone to Mount, and then you would have taken some road. I forgot all those stuff. Almost 16 years from Chennai, away from Chennai. So, dynamic routing protocol is like that. Beforehand only you will know, not after going to the final or the blocking place. Static route is slow in convergence. Meaning what? If any change occurs, after someone complaining, you will go and change the static route. You will delete the early path because the change has happened and you will put the new path. Very slow, no? If no one complained about the failure of a link, then you will not know. All the packets will be going and getting dropped till you find it. Whereas dynamic routing protocol, in very few seconds, they identify there is a failure in a path. They immediately change the routing table with a new path without we, the administrator, interfering. So dynamic routing protocols are fast in convergence. Not only that, dynamic routing protocol updates the routing table dynamically. Administrator need not to know the complete topology. Administrator needs to just enable the protocol on each router. The routers will start talking among themselves, sharing their informations that they have which makes the routers to learn the networks which are connected to some other routers. See, dynamic routing protocol is enabling the routers to communicate among themselves, advertise the informations that they have to other routers, so that all routers will have complete knowledge of the topology. Every single router in the topology will start talking, so that all will have a complete knowledge. When I was doing my MCA, with one of my friend, I followed this method of studying. I will study some portion, he will study other portion. We both are very good storytellers. So before exam, he will tell all that he studied in like a dialogue, normal story. I'll tell in my own language what I studied. So now we have completed the whole book with less effort. That is what dynamic routing protocol does. Every router will share the networks they know to other routers. And the other routers will learn from friends through advertisement. Every router will advertise and also learn from others' advertisement. Dynamic routing protocol is also fast in convergence. When any link goes down, when a network goes down, immediately a trigger update will be sent to every router saying that network is down. Remove the route from the routing table. As soon as the route is removed, if there is any other alternate path to that same network, that will come into routing table. Not only that, if you have multiple paths to a destination with same metric, up to 4 paths will be by default used to do equal cost load balancing. Equal cost multipathing. So when you have multiple paths, dynamic routing protocol can use those multiple paths to share the load so that the data can reach the destination at the earliest. Dynamic routing protocols are the best way of learning routes in a very large network, medium and large scale networks. Compared to static route, security wise, static route is best. Security wise, static route is best. Why? We only write the route. Our traffics are going according to the route that we gave. Whereas in dynamic routing protocol, the routes are determined dynamically. So administrator will not have a 100% surety, 100% clear on which path the packets are going currently. Because the path is not be given by administrator, it has been determined by the dynamic routing protocol. So If the route is given statically, administrator will have control over the topology. So that sounds like a advantage of static route, but still, you cannot depend on static route in a medium and large scale network. See, in our Indian, especially South Indian custom, parents will be like an eagle, always watching their children, how they go, what they do, are they going in a right path, are they studying well. But how long the parents can go? Maybe if children are going in school bus, they will go up to school bus. If they are going to drop, they will go up to gate. That's all you can do. That's all you can do. What will you do when they are after 12th? You can't do anything. Parents don't even understand the syllabus that they are having. So, not possible to follow children till they get settled well. Not possible. Same story. That cannot be called as an advantage of static route. If I write a static route, I have a control over the path selection. I know how the packet will go. If I enable dynamic routing protocol only decides the path. I will not have control. It is okay. Let the protocol decide the path. Protocols can have better control over the path selection than static route. I just told no. When a path goes down, immediately dynamic routing protocol will go and tell every router the path is down, so that all router will remove it. But can a static route do that? Then how can we say it has got better control? In all ways, dynamic routing protocol is the best. So whatever we learned yesterday and day before yesterday in static route, are they waste? No, 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 no. I'm not saying that. It is important. We do use static route and static routing and dynamic routing mixed in most of the environment. We will enable dynamic routing protocol, but in some important places we will also have static route. So on those important places, you have both dynamic route as well as static route. Which one router will follow? Static route. Though dynamic routing is also running on that router, for static route, those routers will give importance. You see, when you have both static route and dynamic routing, static routing is preferred because administrators' decision is what the static route is. Administrator only wrote the routes. So it gives more importance to what the administrator is typing than what the protocol is dictating. See, so static route is also very important. Default route, static route, all that you learned are not waste. Now let us get into this first routing protocol called routing information protocol. Routing protocol. This is a routing protocol which is classified under distance vector. Distance vector routing protocol. You see, I just told you RIP is a distance vector routing protocol. This distance vector routing protocol uses Bellman-Ford algorithm. What this Bellman-Ford algorithm will do, it will periodically advertise the routing table. A copy of the routing table will be periodically shared. How often? Every 30 seconds. Every 30 seconds, every router will advertise what they have in their routing table. When they advertise the networks from the routing table, they also advertise with the metric. What is metric? Metric is the way that which you decide whether the route is best or not. எங்க தமிழ்நாட்டுலலாம் மல்லிகைப்பூ ஒரு மெட்ரிக்கோட வாங்குவாங்க. அந்த மெட்ரிக்கு யாராவது பேர் சொல்லுங்க பார்க்கலாம். How do they buy jasmine in Tamil Nadu? ஒரு முழம், 2 முழம். That is the metric. It is not centimeter or kilometer or millimeter. It is Tamil Nadu style meter. நல்ல வேளை சைனீஸ் முழம் போடல. அவங்க கையில ரொம்ப குட்டி குட்டியா இருக்கும் பாருங்க. So how do you measure path? For example, if you take router 1, which is trying to go to this destination, for router 1 to reach the destination, there are 2 paths. One via router 2, which has got 3 hops. 1 hop, 2 hop, 3 hop. Whereas this side, it is 2 hop. This is the metric. Measuring the best path. Using hop count is what the distance vector routing protocol will do. Their metric is hop count. 3 is one metric, another path just 2 is the metric. So RIP will say going via router 4 is the best path. This is the best path. Why? Because the metric for RIP is hop. Hop. This is one hop. Another hop. Hop means what? Jump. Hopping. Hopping. Like sack race, no? We used to go sack race in school days. I always come first in that. I'm very good in jumping. Sack race. Hopping. So the path with the less hop count is the best path. That path only will be kept in the routing table. See, in this routing table of R1, you will not find this path to reach this destination. You will only find this path. Even though there is another path, it won't be available. Maybe when this goes down, for some reason, let's say the link has gone down. Then this advertisement will stop coming. It won't come because the link has gone down about this destination, R4 will stop talking. R4 will stop advertising. That time, R1 will remove this path, after which it will learn another path via this direction. So it will put this path in the routing table. See, when there are unequal cost path, or this cost paths, or the cost of this paths equal, no. This path is 3 metric. This path is 2 metric. Compare the cost. This is lower. Lower is the best one. Lower is best one, no? When you're trying to go somewhere abroad, we try to go through the airlines which is cheaper in price. Same destination. Why we need to give more price? இங்கேருந்து ஏறி உட்காந்தால் 4 மணி நேரத்தில் துபாய் போயிடலாம். அந்த 4 மணி நேரத்துக்கு எதுக்கு நிறைய செலவு பண்ணணும்? இந்த 4 மணி நேரம் கொஞ்சம் கஷ்டப்பட்டு போயிட்டு ஒரு 2 நாள் எக்ஸ்ட்ரா அங்கே ஹோட்டலில் தங்கலாம் பாருங்க. அந்த காசுக்கு ஒரு 2 நாள் எக்ஸ்ட்ரா துபாயை பார்த்த மாதிரி இருக்கும். சில பேர் போற பெருமைக்கு எமிரேட்ஸ்ல தான் நான் புக் பண்ணுவேன்னு பண்ணுவாங்க. அது மற்ற ஏர்லைன்ஸை விட டபுள் மடங்கு ட்ரிபிள் மடங்கு அதிகமாக இருக்கும் ஃப்ளைட் சார்ஜ். அப்புறம் அங்கே போயிட்டு கஷ்டப்பட்டு இருப்பாங்க. அங்கே போயிட்டு ஒரு கஞ்சத்தனமான ஒரு ஹோட்டலில் 4 முழுசும் தங்கிட்டு இருப்பாங்க. அதை இங்கே காமிச்சு ஒரு 4 மணி நேரம் அட்ஜஸ்ட் பண்ணிட்டு அங்கே நல்ல ஹோட்டலில் கௌரவமா 2-3 நாள் நல்ல பெரிய ஹோட்டலில் சூப்பராக ராஜா மாதிரி இருக்கலாம் இல்லையா? இதெல்லாம் ஒரு டிப்ஸ். ஃபியூச்சரில் போனீங்கன்னா அப்படி யோசிங்க. இந்த தப்பெல்லாம் நானும் பண்ணியிருக்கிறேன். ஆனால் ஃப்ளைட்டில் உட்காந்து போகிறதும் கஷ்டம்தான். எந்த ஃப்ளைட்டில்? இந்தியன் ஃப்ளைட்லாம் இந்த ஸ்பைஸ் ஜெட்டு ஒரு மாட்டு வண்டி மாதிரி இருக்கும். வெஸ்டரா அது இன்னொரு கட்ட வண்டி. இந்தியன் ஏர்லைன்ஸ் சொல்லவே வேணாம், அது ஒரு தகர டப்பா. எல்லாமே இந்தியன் ஏர்லைன்ஸ் எல்லாம் ஒரு டவுன் பஸ் மாதிரி ஆயிடுச்சு. கௌரவமா போனோம்னா எமிரேட்ஸ் ஒண்ணுதான் இருக்குது. ஆனா என்ன பண்றது, காஸ்ட் அதிகம். கொஞ்சம் அப்படி பல்ல கடிச்சிட்டு ஏதோ ஸ்பைஸ் ஜெட்ல எதையோ போயிட்டீங்கன்னா 2 நாள் எக்ஸ்ட்ரா நல்ல ஹோட்டல்ல இருந்துட்டு வரலாம் நீங்க. So metric always lower is best, lower is best. Cheap priceல போயிடணும், அதுதான் பெஸ்ட். அப்படி சீப் பிரைஸ்ல போயிட்டு கொஞ்சம் சேர்த்து வச்சுட்டு அந்த டிக்கெட் காசை கொஞ்சம் கம்மி பண்ணிட்டீங்கன்னா அங்க போனீங்கன்னா கோல்டு சூக்குன்னு ஒரு தெருவே இருக்கும். அங்க கான்ஸ்னு ஒரு கடை இருக்கும், மூளைக்கு மூளைக்கு ஒரு கடை கான்ஸ்னு இருக்கும். அது என் ஃபேவரட் நகை கடை. அங்க ஒரு சவரன் எக்ஸ்ட்ரா வாங்கிட்டு வந்துடுவேன். So lower is always best, you see. Hop count, lower is best. If you go this way, it is 2 hop. If you go this way, it is 3 hop. Which is best? Lower is best. Metric, lower is best. The routing table received from neighbor is used by each router to form its own routing table with the best path to each network. See, router 4 is giving you the destination as 2 hop. To go to that destination, it is 2 hop. Router 2 is giving same destination with 3 hop. So what this router which is receiving these 2 updates, one update is saying 3 hop, another update is coming with 2 hop. The receiving router, what it will do, it will decide its own path by comparing the metric. And router 1 decides to choose this path as the best path. Decision is made by this guy only. A recommendation is given by these two guys. Hey, come, I'll take you just 3 hop. The other one is saying, hey, come, I'll take you 2 hops. Which one R1 will pick? By comparing the metric, it decides its own route for the routing table with the best path for each network. So as I said, the router knows only the next path and have no knowledge of topology. This guy has got no idea other than these two guys. It knows this destination, but to reach this destination, I have one next hop, which is router 4, which is my best path because the hop count is 2 if I go this way. The other next hop is this guy, which is 3. That's all it knows. The routers know only the next hop and have no knowledge of topology. Which router? The router that runs distance vector. Please understand, I'm not talking about all routing protocol. We are under the title called distance vector routing protocol. Distance vector routing protocol only knows this one and this one. சில பேர் வெளிநாட்டுக்கு போறேன், படிக்க போறேன், வேலைக்கு போறேன், என்ன பண்ணுவாங்க தெரியுமா? நல்லா இருக்கிற சொத்தை, இந்த தென்னந்தோப்பு, புளியந்தோப்பு, அப்புறமா இந்த அரிசி, நெல் விளையிற பூமி, இது எல்லாத்தையும் வித்துட்டு யார்கிட்ட தெரியுமா கொடுப்பாங்க? அந்த R4 மாதிரி R2 மாதிரி ஒரு திறப்பான். அவனை மட்டும்தான் அவங்களுக்கு தெரியும். அவன் சொல்றதுதான் உண்மை நினைச்சு மொத்த கதையும் தெரியாது அவங்களுக்கு. அந்த டெஸ்டினேஷன் வரைக்கும் இருக்கிற கதை தெரியாது. டெஸ்டினேஷன் வரைக்கும் இந்த கதையெல்லாம் தெரியாது. இந்த கதையை மட்டும்தான் தெரியும். ஏன்னா இவங்க இந்த ஊர்ல இருக்கிறாங்க. இந்த ஊர்ல இருந்துகிட்டு பக்கத்து ஊருக்கார் என்ன சொன்னா, எங்க அப்பா ஃப்ரெண்டு என்ன சொன்னாரு, அப்புறமா மும்பைக்காரன் ஒரு ஏஜென்ட் என்ன சொன்னான், அது அப்படியே உண்மை நம்பி அவன் கேட்கறதெல்லாம் வித்து வித்து கொடுப்பாங்க. கொடுத்துட்டு இங்க எப்படியோ அடிமை மாதிரி போய் சேர்ந்துருவாங்க. அப்புறம் டொனால்ட் ட்ரம்ப்னு ஒருத்தர் வருவார், பட்டை கிளம்புவார், வந்து விழுந்துருவாங்க திருப்பி. That is why you should know the complete story. You see, RIP is not good protocol when it comes to the knowledge of topology. Distance vector routing protocol, they don't have the real complete knowledge of the whole topology. They know only the next hop. இந்த பாயிண்ட் நீங்க இன்டர்வியூல பேசுனீங்கன்னா அந்த மாதிரி ஒன்றும் புரியாது. உண்மையிலே இது செம்ம பாயிண்ட். இது டிஸ்டன்ஸ் வெக்டர் புரோட்டோகால்ல வந்து தெரியும்னு காமிக்கிறதுக்கு ஒரு அருமையான பாயிண்ட் இது. In distance vector routing protocol, routers will not know the complete topology. They know only the next hop. இது யார் சொல்லி நான் கேட்டதே கிடையாது. அப்படி மட்டும் சொன்னாங்கன்னா அவங்களுக்கு நல்லா தெரியுதுன்னு அர்த்தம். நல்ல டிஸ்டன்ஸ் வெக்டர் புரோட்டோகால் தெரியுதுன்னு அர்த்தம். So this is an important point to differentiate the other routing protocol from a distance vector routing protocol. Don't forget this point. Distance vector routing protocol don't have complete knowledge of topology. அப்படின்னா என்ன அர்த்தம்? பின்னால ஒரு புரோட்டோகால் படிக்க போறோம், அதுக்கு கம்ப்ளீட் டோபாலஜி தெரியும்னு அர்த்தம். இதுக்கு தெரியாது. That's what it means. This protocol do not know. The other protocols yet to come, they know it. This is one of the drawback of distance vector protocol. RIP is one of the distance vector routing protocol. சொல்ல போனா இது ஒண்ணு மட்டும் தான் distance vector protocol. Which one? RIP. Routing information protocol. So far what you have learned is, what is a distance vector routing protocol and which protocol is distance vector routing protocol. RIP is the distance vector. That's all you have learned. What is the metric of RIP? Hop count. Why? Because RIP comes under distance vector protocol. And how this protocol, distance vector protocol, advertises their routing table? Periodically. Periodically means what? Whether there is a change or not, it will advertise. That is what periodically. You see these aeroplanes, periodically it will send a ping message to the ground. The aeroplane கோளாறு நடக்கலனாலும் periodically ஒரு ping message வந்துட்டே இருக்கும். ஃப்ளைட்ல இருந்து வேரியஸ் பார்ட் ஆஃப் த ஃப்ளைட்ல இருந்து வந்துகிட்டே இருக்கும். விங்ல இருந்து வரும், டெய்ல இருந்து வரும், இன்ஜின்ல இருந்து வரும், பைலட் உட்காந்துருக்க கார்பெட்ல இருந்து வரும். ஒரு பிங் மெசேஜ் வந்துகிட்டே இருக்கும். ஒரு ஃப்ளைட்ல இருந்தும் ஒரு 4-5 பிங் மெசேஜ் வந்துகிட்டே இருக்கும் கீழே இருக்கிற கிரவுண்டுக்கு மட்டும் இல்லை. இந்த ஃப்ளைட்டை தயாரிச்சு அனுப்புனா பாருங்க, போயிங் அந்த மாதிரி கம்பெனி, அவனுக்கும் போயின்னு இருக்கும் ஒரு பிங். நான் வித்த ஃப்ளைட்டினுடைய ஸ்டேட்டஸ் எப்படி இருக்குது, நல்லா போயின்னு இருக்குதா அப்படின்னு அவனுக்கும் தெரிய வச்சுட்டே இருக்கும். அவனுக்கும் தெரிஞ்சுக்கிட்டே இருக்கும், என் ஃப்ளைட்டு நான் வித்த இந்தியாவுக்கு, அது இப்போ அங்க பறந்துட்டு இருக்குது பிரான்ஸ்க்கு மேல அப்படின்னு வித்தவனுக்கு தெரியும். Because that flight is sending ping message periodically, status. Even when it is very good in condition, the periodic message will be sent. That is periodic advertisement. Whether there is a change or not, the entire routing table will be sent to the neighbors every 30 seconds. அந்த ரவுட்டிங் டேபிள் மாற்றம் வந்திருக்குதோ வந்து இல்லையோ, வந்தாலும் வரலனாலும் ஒவ்வொரு 30 வினாடிக்கு ஒரு முறை ரவுட்டிங் டேபிள்ல இருக்கிற மொத்த ரூட்டையும் அனுப்பும். அப்ப பக்கத்துல இருக்கிறவனுக்குலாம் அது கேட்கும். அவன் என்ன பண்ணுவான், அதை வாங்கிக்கிட்டு அப்டேட் பண்ணிப்பான். So every router advertises every 30 seconds the complete routing table, so that the receiving router will refresh their routing table as per the advertisement. But one thing you should know, if there is any failure, it won't wait for 30 seconds to come. Immediately it will send to everyone. If there is a new network coming in, immediately it will advertise. Immediate. We call it as trigger update. See, there are 2 updates here: periodic update, trigger update. Trigger update is whenever the change happens, the change is instantly sent to everyone. Flash news, it will be flashed to everyone. Apart from this instant message about the failure or notification, there is also periodic message, which is every 30 seconds. RIP is IGP protocol. See, routing protocols are classified into IGP and EGP. One is interior gateway protocol, another one is exterior gateway protocol. Exterior gateway protocol example is the one and only BGP. IGP protocols, there are many. One of them is routing information protocol. RIP is an example for interior gateway protocol. Now, what is this interior gateway protocol? BGP is an exterior gateway protocol. We'll come to that one later. Now, what is this interior gateway protocol? The protocol that is recommended to be used within autonomous system, within an office, within an enterprises. It is not between one company and another company. It is within one company. It is within one organization. This is not recommended to be between organizations. Whereas BGP is an exterior protocol which is recommended for in between of autonomous systems, connecting between multiple service providers like Airtel, Idle, Etisalat, Orido, French Telecom Italia. Now to connect between the ISPs, we need BGP. We cannot use RIP there. RIP is used within an organization. It is an interior gateway protocol designed to use within small autonomous system. All right. All other stories are not that important in this page. You can read it later. There is a limitation of RIP. We already learned one limitation. What is that? RIP, because it is a distance vector protocol, the distance vector protocol will not have complete knowledge of topology. That's one limitation. The other limitation is the metric that you learned, what is the metric of RIP? Hop count. Every jump is one hop. RIP can handle only up to 15 hops. It can handle only up to 15 hops. If there is a router in 16th hop, RIP cannot learn. See, you have a walkie-talkie, you have a cellular phone. With your walkie-talkie, you can talk from your third floor to ground floor. If it is little bit extra powerful, you can take it to the market also, which is like less than 3 kilometers. You can talk with walkie-talkie to your home. But 25 kilometers away, if you want to talk to your home, you need cell phone. Your walkie-talkie won't work. For domestic people, for normal people, we don't have that powerful walkie-talkie to support 25 kilometers. Not allowed. Frequencies are not allowed to use. See, there is a limitation for walkie-talkie. Only for 3 kilometers, within 3 kilometers, things like that. You cannot use that between cities. Definitely not. But you can use cell phone. RIP is like a walkie-talkie only. In a small organization, that is why it is said here, small autonomous system. You see the word small. Yep, small. This is one big limitation. People will always say about this point when they are in an interview. They will say, hey, RIP is not a good protocol. Why, it cannot support more than 15 hops. Doesn't mean that it is not good protocol. Walkie-talkie is still needed. Your cell phone tower may go down one day if there is a solar storm, but walkie-talkie won't go down. RIP is also like that. In its place, it is important. There are a lot of places where RIP is best. Later, when we come to CCNP, I'll show you those places. So, RIP is also a very good protocol, though it has got this limitation, still they are important. Network intensive table update, meaning it will send the update every 30 seconds, consuming the bandwidth every 30 seconds. Even when there is no change, the entire routing table will be sent as an advertisement, consuming the bandwidth from every router it goes. Network intensive table update. So this advertisement will go and disturb the other guy. Take it. The other guy will think, I'm going to learn something new, but it is the same thing. Every 30 seconds, something new is coming. But it's the same thing. Unnecessary process, unnecessary bandwidth. Network intensive table updates. Compared to all other routing protocol, RIP is slow in convergence. See, don't compare to static route. Static route is not a routing protocol. Compared to static route, this is far, far, far better. I don't know if RIP is compared to a tortoise. I don't know what to compare static route. Static route is like on stick. Maybe when a heavy wind blows, it will move. Otherwise, it won't move. Relatively slower means compared to other routing protocol, RIP is slower only. Why? You see here we have two paths. If this path is failed, if this link has gone down, to remove the route from the routing table, it will take 240 seconds. To remove this route with 2 hop, it takes 240 seconds. Only after removing this route, this path can be installed into the routing table. So you need to understand this very well. ஒரு புதிய பாதையை எடுக்கணும்னா பழைய பாதையை சுத்தமா கழட்டி விட்டுடணும். அப்பதான் புதிய பாதையில நுழையவே முடியும். தமிழ்ல சொல்ற மாதிரி கூழுக்கும் ஆசை மீசைக்கும் ஆசைன்ற மாதிரி அதெல்லாம் ஆகாது. ஒண்ணு மீசைய சுத்தமா வழிச்சிட்டு கூழ் குடி, மீசை ஒட்டாது, மீசையில ஒட்டாது. So have to remove this route completely in the routing table. Only then this route can be taken. To remove this, it takes 240 seconds. 4 நிமிஷம், 4 minutes. ரெண்டும் ஒண்ணுதான். 240 செகண்ட்னாலும் ஒண்ணுதான், 4 நிமிஷம்னாலும் ஒண்ணுதான். It takes almost 4 minutes to remove the old route. After which only the new route can be installed into R1's routing table. That is why it is slow. The other protocols will not take 4 minutes. They will take few seconds. For example, RIP will take, EIGRP will take maximum of 15 seconds only. This took how many minutes? 4 minutes. The other protocol will not take this long. As I said, EIGRP will take less than 15 seconds. EIGRP. Likewise, OSPF, ISIS, they all take very less, in few seconds. Only RIP takes longer comparatively. So relatively RIP is slower in convergence. Convergence mean what? Adapting to the change, the new change. That is convergence. In psychology, personality எப்படி சொல்லுவோம்னா நல்ல டாலா வெள்ளையா செம்மையாகிறான்ப்பா அதெல்லாம் சொல்ல மாட்டோம். ஒருத்தன் பர்சனாலிட்டி எப்படி சொல்லுவோம்னா எந்த சூழ்நிலையிலையும் அவன் சமாளிச்சிடறான்ப்பா. என்ன சூழ்நிலை வந்தாலும் கலங்காம ஆள் ஸ்ட்ராங்கா சாலிடா அதை வின் பண்ணி வெளியே வரான்ப்பா. செம பர்சனாலிட்டி. தட் இஸ் வாட் ரியல் பர்சனாலிட்டி அக்கார்டிங் டு சைக்காலஜி. Whatever the situation may come, he will know how to face it. He won't sit and cry or go to a liquor shop and drink and spoil his own health like an brainless. That is real personality. The one who can face everything that comes in his life. அப்படி இருக்கிறீங்களா? வளர காலத்துல ரொம்ப போராட்டம் வரும். நானும் பார்த்துருக்கிறேன் எல்லாத்தையும். அப்போ இதுதான் எனக்கு ஞாபகம் வரும். நான் சைக்காலஜியில் படிச்சுதான் ஞாபகம் வரும். டேய் நீ நல்ல பர்சனாலிட்டி தான், பெருசா ஸ்டாலாலாம் இல்லை, வெள்ளையாலாம் இல்லை, சிக்ஸ் பேக்லாம் கிடையாது. அட்லீஸ்ட் இந்த பர்சனாலிட்டியாச்சும் வச்சுக்கலாம் நம்ம. என்னது என்ன வந்தாலும் பார்த்தெல்லாம் வரட்டும், கடவுள் என் கூட இருக்கிறாரு, நான் ஏன் பயப்பட போறேன், கடவுள் எனக்காக ஃபைட் பண்ணுவாரு, எனக்கு ஒன்றும் பிரச்சனை கிடையாது. I will be the winner in the end. That confident that God is in me and I will not lose the battle. That has brought me safe and sound in all difficulties. Why should I care when the trouble comes? When my Creator is my friend. When I live a life which Creator likes, He will be there also to fight for me when there is a trouble. That is real personality. So that if you will also have in the growing phase, Sarvana, Ananda, when you also have this attitude, God is there to fight for me. Whatever the trouble comes, I will only be a winner. I will not get discouraged. Then you will be one day a winner. That's one of the lesson I learned when I was in 20s and 30s. Now I'm 46. Right. So this is relatively slow compared to other protocol. Slow in convergence. The other one is no support for variable length subnet masking. Meaning you cannot go and tell RIP, I have only this network. I have this 10.1 network. No, RIP won't understand. Is this class full? No, it is variable length subnet mask. What is the real subnet mask for 10? It is /8. If you tell this 16 for 10, RIP will not understand. RIP will take it as 8 only. RIP understands only that fixed length subnet mask, not the variable length subnet mask. But when you enable version 2 of RIP, all this you saw is version 1 story. In version 1, these things are same. In version 1 and 2, these 3 points are same. In 2 also, limited hop count, 15 hops. Every 30 seconds, it will send periodic update even when there is no change. Slow in these things, these 3 things are same. What is the difference thing? This one. Version 2 understands your 16 mask. VLSM. Version 2 understands that CIDR notation, classless interdomain routing notation. Not only that, version 2 uses multicast address called 224.0.0.9 to send the update. Version 1 will use a broadcast address. Version 1 will use this address to send update. If you send anything to this address, it will go to everyone on earth. The printer that is connected, the scanner that is connected, the cell phone that is connected, the laptop that is connected, even they all will get the RIP update. Is there any use of RIP update for your laptop? No. But version 2 is not like that. Version 2 sends to a specific address 224.0.0.9. When a packet is sent to this address, only RIP running routers can open this packet. Your laptop will not open this packet. Printer cannot open this packet. Only the RIP running routers can open the packet. When there is an envelope with a to address for all Indians, when it is written like for all Indians, will someone from Malaysia open it? No, they won't open. But if there is a packet which is written with to address for all human being, then everyone will open. But after opening, inside the envelope, if it is written for Japanese in Japanese language, then what you will do? You will drop it. A waste of time, man. It has wasted my time. I thought something interesting. It's for me. I thought it is something very interesting. I was very curious, but when I opened it, it's all in Japanese language. See? But here it is not like that. If the packet needs to go to all Japanese, it is very clearly written Japanese only. 224.0.0.9 means what? For RIP running routers only. This updates. Not only that, between two routers, before they share the advertisement, before they learn each other, they authenticate. Again, it is not enabled by default, we can enable it. திருச்சிக்கு போகும் வழி அப்படின்னு நான் ஒருத்தனை கேட்குறேன்னு வச்சுங்க, போய் ஒரு வழியில ஒரே இருக்கிறேன், கிருஷ்ணகிரி தாண்டி போயிட்டு இருக்கிறேன் பெங்களூர்ல இருந்து. ஒரே கன்ஃபியூஷனா இருக்குது, எப்படி போறதுன்னு தெரியல. திருச்சிக்கு எப்படி போறது? கும்பகோணம் வழியா திருவண்ணாமலை வழியா போகணுமோ, என்ன பண்ணலாம் அப்படின்னு மண்டே சொரிஞ்சிட்டு இருக்கிற நேரத்துல அத்தன்டிகேட் பண்ணுவோம். ஃபர்ஸ்ட் நான் கேட்க போற ஆளுக்கு தெரிஞ்சு இருக்கணும். யாரையோ கேட்டு அவன் சொல்ற பக்க பிரகாரம் போனா சேலத்துக்கு போய் சேர்ந்துருவேன். டைரக்ஷன் மாறி போய் திருச்சிக்கு போக முடியாது. ஸோ முதல்ல செக் பண்ணுவேன், இவனுக்கு தெரியுதா, இங்க தமிழன் தானா, தமிழ்நாட்டுக்காரன் தானா, தமிழ்நாடு ஃபுல்லா தெரியுதா இவனுக்குன்னு செக் பண்ணுவேன். அப்படியே அத்தன்டிகேட் பண்ணுவேன். என்னங்க திருச்சியில ஒரே வெயிலாமே எப்பவுமே? ஆமாங்க. அது ஏன் கேக்குறீங்க? ஒவ்வொரு வருஷம் இதே தொல்லைதாங்க. இவன் தான் சரியான ஆளு. இப்போ எப்படி லெஃப்ட்ல போயிட்டு போலாமா, இல்ல ஸ்ட்ரெயிட்டா போலாம்? ஸ்ட்ரெயிட்டா போயிடாதீங்க, ஈரோடு சேலம்னு போயிருவீங்க. லெஃப்ட்ல போங்க, அப்படி திருவண்ணாமலை ரோட்டுக்கு திரும்புங்க. அதுதான் நம்பகமான வழி. Even routers also does the same thing. Before learning an update, someone is advertising. I cannot learn all the advertisement. What if they give wrong route? What if that router is being controlled by a bad guy, making the router to give my router a wrong route to destination? So I have to authenticate before I learn. Authentication is important for routing protocol. இல்லைன்னா முடிஞ்சிச்சு. போயினே இருப்பீங்க. ஈரோடு வந்துச்சு, அந்த திருச்சி வந்துச்சுன்னு பார்த்தா ஒரே பச்சை கலர் பெயிண்ட் அடிச்சு ஃபுல்லா ஊர் ஃபுல்லா இருக்குது. என்னடான்னு பார்த்தா சேலம். சேலம் ஒரே பச்சை கலர் பெயிண்ட் தான். 2 அடுக்கு பிரிட்ஜு பச்சை கலர், எங்க பார்த்தாலும் பச்சை கலர் பெயிண்ட் தான். இது எங்க கேள்விப்பட்ட பேர் இருக்கு. சேலத்துக்கு வந்துட்டோமோ? ஆமா, தப்பான ரூட் சொல்லிட்டான் அவன். லெஃப்ட் சொல்றது போய் ஸ்ட்ரெயிட் சொல்லிட்டான். That's dangerous, you see. Routers are like that board on the route. You see the direction board? If the direction board பழைய தமிழ் படத்துல என்ன பண்ணுவோம், வில்ல அப்படி 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 திருப்பி விட்டுருவான் இந்த டைரக்ஷன் போர்டை, ரொம்ப ஸ்மார்ட்டா. அப்ப நம்ம ஹீரோ குதிரை ஓட்டிக்கிட்டு ஆப்போசிட் டைரக்ஷன் போயிடுவாரு, போய் வில்லகிட்ட மாட்டிப்பார். அந்த மாதிரி நிலைமை ஆயிரும் அத்தன்டிகேட் பண்ணலன்னா. Authentication is very important for routing protocol, especially when the routing protocol works in public. Within an organization, you may not need it, but support is there. If you want, you can enable. In version 1, you don't have that support. Version 2 of RIP supports authentication. Okay, so we have seen some introduction to RIP. Podcast is limited, slow in convergence. Not only that, the advertisements are sent in clear text. Authentication is also in clear text. If someone wants to know the password between two routers, they can easily use a Wireshark. You remember when I was telnetting, I was showing you all the passwords. So if you use Wireshark, you can also tell the password which RIP uses. Authentication is supported but not strong. Right. RIP also has got another version called NG version. See, we have seen version 2, version 1. Yeah. Version 1 and 2 are IPv4 version. NG version is nothing but next generation. It is IPv6 RIP. Everything is same story. That is also this RIP NG also distance vector routing protocol only. It is same like RIP version 2. Algorithm is Bellman. Timer is same 30-second periodic update. 240-second is the flush interval. Remove பண்றது routing table. After 180-second, they come to a conclusion that possibly down. I'll talk about this in tomorrow's class in detail. Same limitations what you saw in RIP version 1 and 2. All right. So we'll stop here. We'll continue.